All right, so we're going to talk about the very last section of Unit 3. So we should be wrapping a lot of this trig up. And we're ending in a way that honestly a lot of this is taught during geometry. For most of you it's considered sophomore geometry. And so some of these things may sound familiar. And if they don't, that's okay. I'm just going to reteach it all again. But I'm going to use a couple different things here. So basically go ahead. I know I was able to do this with some of you in class, and with time, because of our delay, I want to make sure you have all this with the snow delay this morning. So an angle of elevation and an angle of depression is basically thinking about if you were standing, let's say, on the ground, and you were looking up at a plane in the sky. The angle that is formed by this horizontal line, which obviously these lines are imaginary, we don't see this, so it could be the grass, it could be, the concrete, whatever, but it's slope of 0, horizontal, and this angle that's formed from your eyes looking up is called your angle of elevation. So, and you can go ahead and copy down what I have in purple, but it's the angle formed by a horizontal line and the line of sight, which is right here, to an object above this line. Now, the angle of depression then, that's going to be pretty easy to understand because you also think of maybe this horizontal line as the sky, the clouds. And if you're in an airplane and you're looking down, this is called your angle of depression. And that angle is formed from this horizontal line, and it's in between the horizontal line and the line of sight looking down. So those are the official definitions, and basically we're going to talk about down here in this example that these angles are actually equal. And this stems from, if you know that two lines are horizontal, they're parallel because they have the same slope. So back in geometry, if two lines that are parallel are cut by a transversal, someone kind of guessed at first though, these are called alternate interior angles. And you don't need to know that, but it just kind of connects some of that geometry. And we're going to talk about it in this first example, okay? All right. So in this first example, it says, suppose that a person is looking up. So here you're standing, here's your eyesight, your eyeballs. So this horizontal line here, kind of parallel to the ground, this 38-degree angle is called your angle of elevation. But at the same time, a person in the hot air balloon sees you on the ground. And so that angle is called an angle of depression. So it's between this horizontal line and it's looking down. So if you'll notice, these angles are equal. And what I've done is I've marked these, that's just the symbol for parallel. And it says, what do you notice about the relationship between these two angles? And obviously they're equal. And to kind of stem off of, high school geometry that you took probably a couple years ago, and once again, this is not something that you need to have memorized as far as all of this, but just knowing that these are congruent angles because these parallel lines that were kind of cut by this line of sight transversal, because those are parallel, these are called alternate interior angles, and they're congruent because those lines are parallel. So if someone gives you an angle of depression, but not the angle of elevation, you now know that it would be 38 because they are congruent. Okay? So that's really just the background and kind of the definitions. So we're only going to do 3 short examples, and I know I got one of these done in class, but just to kind of make sure that you're good to go. Typically, I'm going to give you a diagram on some of them, and then I'll kind of taper off and have you draw your own. So you always want to draw a picture. And I think these first 3 examples are pretty easy. I don't think anything is going to be so tricky, but you have to think a little bit, and drawing that picture helps, okay? So it says a palm tree cast a shadow of 18 feet long. Well, just like we talked about up above, that these horizontal lines are parallel to each other. If you have this tree, and just like when you're in the doctor's office and they tell you, we want to get your height, they're assuming that you're standing perpendicular to the floor. So we kind of have to know that this right here is a right angle. Now, if you can't see on the palm tree picture, you can always kind of recreate. So here's your tree, and here's the shadow. And then what happens is this is our line of sight. So we have this 90-degree angle. Now, if you want to mark it right on your picture, the shadow, which obviously would be on the ground, is 18. So I'm going to write it out here so you can see it. And then our angle of elevation of the sun. Well, the angle of elevation means you're looking up. And some people are like, well, the sun's up here. Well, what it means is that the sun's back here. So it's casting this angle right here on the outside is casting down. So the angle of elevation would be equal to that. And this would be 25.7 degrees. So what you're using is you're using the information given, in a sense, on a right triangle, which belongs in our trig chapter, and they want us to find the height of the tree. So once again, I'll put it on both places so you can kind of see. So really, this is almost like some of those problems we've done in warm-ups and things where it's like solve the triangle, but we don't need to know, this inside angle, even though we know out here is 38, here, 25.7, 25.7, but we want to find this missing leg. And so if you think about it, from this angle, we're looking for opposite, and we know adjacent. So that sounds just like the tangent function. So we can set up the tangent of 25.7 degrees equals opposite over adjacent. And now we solve. And of course you can use your calculator but you want to make sure you're in degree mode. So I'm going to multiply both sides by 18 to get our variable by itself. And now you can literally type in your calculator 18 times the tangent of 25.7 degrees. And we want to round to the nearest hundredth, and to be consistent, I'll try to do that every time. And so that means the height of our tree is about, because I'm approximating, 8.66 feet. And that's it. That's all we're doing for number 3. Okay? All right. If you want to try the other two, push pause and then check, you can, or do them with me. It kind of came out a little dark, so I'll try to kind of redraw and see if you can see what we're doing. But basically, we have kind of like a mountain here, and it says that a sign on the bottom of the mountain indicates that the road will incline 10.5 degrees. So I know it's really hard to see, but there's a dashed line here, and then there's a dashed line here, and this is the road. So I'm going to draw this big line right here. That's our road. So I'm going to draw this out here so you can kind of see. So if that's our road, I tried to draw in the diagram that you have these dotted lines, okay? So what happens is we have our right triangle again, and it said that the road inclines 10.5 degrees. So that means right here is 10.5 degrees. And it says the altitude for a car ascending up the mountain, so here's our mountain road, is 3,850 feet. So it says find the length of the mountain road in miles. Oh, I messed that up. So we have our right triangle, and you'll see that I've already labeled the angle of elevation. So on the angle of elevation, and I know that because it's going to be a 10.5 degrees incline, so that's going to be between the road and this base of the mountain. And then the other information given is that the altitude, now remember, another word for altitude is height. So we're not thinking here, we're thinking height, perpendicular to the ground, is that the mountain is 3,850 feet up. So from the road to the bottom, this is your 3,850. So it wants you to find the length of the mountain road, which we said was right here, in miles. Now the only thing that you have to be careful here is that this is given in feet. We need miles. Not going to be a big deal, okay? All right, so let's set up our equation. So it looks like if we are going from this angle, we have an opposite and a hypotenuse. So that is definitely a sine function. So I'm going to go ahead and set up my trig equation. And we're going to solve for x. Now, we've done this a lot this year, but to get that x out of the denominator, let's go ahead and multiply both sides by x. And then we can divide to get x by itself. So, once again, using your calculator, if you type in 3,850 and divide that by the sine of 10.5 degrees, that gives you about 21,126.5 feet. Now, normally I'd say we're done, but it wants our answer and the length in miles. So this is where we have to think back to our conversions. There are 5,280 feet per mile. So if we take our answer in feet and divide that by how many feet there are per mile, we will get about 4 miles. Okay? So once again, basic trig equations using your calculator. Just really read the questions so you know what they're asking. Okay? All right. The last example is you are 200 yards from a river, and it says rather than walking directly to the river. So I'm just going to draw my river here. It says you walk 400 yards along a straight path to the river's edge. What is the angle between this path and the river's edge? So since I did not give you a picture, it's really important that you get a good picture set up. So if we are 200 yards from the river, I'm going to go from the river and I'm just going to go, you can go either direction, so it doesn't matter, but I'm going to say that, you know, here we are, and we are 200 yards from the river. And it says rather walking directly to the river. So instead of doing this, we're going to walk along a path. It says along a straight path to the river's edge. So we're going to walk, instead of just right to it, which is kind of perpendicular to it, we're going to walk like this and eventually hit the water over here somewhere. So this is kind of the diagram that we want to use. And we know that this is 400 yards. Now the question they're asking is, what is the angle between the path and the river? So they're wanting us to find this angle, I'm going to call it x degrees, right there. So now that we have enough information, because as long as you have two sides or an angle in one side, you can find any other piece to this triangle. So once again, I'm going to start here. I know opposite over hypotenuse, so I'm going to do the sine of x degrees equals opposite over hypotenuse. And honestly, what's great about this one is you can do this one in your head if you know that unit circle, right? When the sine of what angle measure is a half. So I'm hoping you know that that would be, hopefully memorized, you have that as pi/6. If you don't, but you should, remember you can take the inverse sine of both sides. So x is just going to be the inverse sine of a half. Now you want to be in degree mode because your answer would be in degrees, and that's going to give us 30 degrees, okay? So really, you know, the problems are going to be very similar to this. You might have to think a little bit more and know what it's asking you, but you're going to use this same setup, okay? All right. Your homework, remember, is due on Wednesday by 11:59. Make sure you submit that to Canvas. Okay, thank you.